Here we have a question. It says, do the series converges absolutely, conditionally, or it just diverges? Let's start testing about absolute convergence first, because absolute convergence is the strongest property. Okay. What do we need to prove for absolute convergence? We have the series. If we want to prove the absolute convergence, we want to prove that absolute value of this converges. When you take absolute value, the negative sign disappears. So we are only left with this part of the series. So now the question is, does this converge or diverge? To check this, I can compare this to, this is AN. Let's come up with another series, BN, let's say, which is 1 by root n, right? So what do we know? N plus 1 is more than n, therefore 1 by n plus 1 is less than 1 by n. Square root of that will also be less than square root of 1 by n. But we know that this series is P series with P is equal to half, which is less than 1. So this series diverges. So this is larger. If the larger series diverge using comparison test, we can say the smaller series, this is smaller, right? Smaller series diverge. So we wanted to check about this. This diverges. Therefore, our original series is not. What is the first answer? It's not convergent absolutely. The given series do not converge absolutely. So that is the first part of it. Okay, so we already have claimed this is not there. Now we only left with, so after putting absolute value, this is not convergent. So now what we have to talk about, as given, whatever was given, is this series as is convergent or not? So what kind of series is this now? This is alternating series. So we can maybe try AST. For trying AST, we have to figure out that this is Bn, leaving the negative one part. This is Bn. Obviously, this is positive, right? All Bn's are positive here for all n more than 1. Bn is decreasing for sure. Why? 1 by n plus 1 square root is less than 1 by square root of n. So bn plus 1 will be less than bn. It is decreasing. So first condition, one condition of AST is satisfied. The other condition is limit n approaches to infinity of bn, which is limit n approaches to infinity of 1 by root n plus 1. That for sure will be 0. Why? Because denominator is approaching to infinity. If denominator approaches to infinity, the whole thing will approach to 0. So limit n approaches to infinity, bn is 0 and bn is decreasing. Both conditions of AST are satisfied. Therefore, using AST, the alternating series test, we claim that this series, which was given to us as is convergent. Now, the series is convergent, but it's not convergent absolutely. So what do we call it? It converges actually conditionally. Conditionally means that it doesn't converge absolutely, it just converges as is.